Hello everyone, my name is Greg and I dev stuff. Welcome everyone to episode 7 of Grid Map in Unity tutorial. In this episode we will make the character to move around the map. Today we want to make it possible to select the character and move this character around on the map. We want to select the character. Select main camera, create another new component called character control. Inside the grid control, we have an input which shows the name of the character placed in the tile. So what we need to do is to get the character and store the reference to him in the character control in similar sense. In the character control, create a serialized reference to grid manager and serialized field for target tile map. Then let's copy the process of detecting the position of mouse click. Create a variable for the character. So now store the character into the variable instead of the local variable in the mouse input function. Let's test this. We should be able to see names of the characters stationed in the tile as before. Good, we can select the character. We have a pathfinding system. So what we want to do is to move the selected character around the world based on his capability to reach certain areas. So when you select the character, the area which character can reach should be highlighted. And we should be able to click on the tile and be able to move the selected character to that tile. But before we continue, if you like this video, please consider subscribing and leave a like. This episode is brought to you by generous support of people on Patreon and members on YouTube. If you want to join them, link to my Patreon in the description, and join button available right now on YouTube. So when you select the character by clicking right mouse button on him, we need to calculate and show every space on the map which this selected character can reach. To do so, we want to process every tile we will be able to reach through pathfinding. And when you select the tile, we simply backtrack the paths through this pre-calculated data. Open pathfinding script. We want to create a new method called calculate walkable terrain with two parameters, start x and start y for start position. Now we will mirror the pathfinding, but instead of searching for paths, we will calculate all the h values for each tile our character can reach. Get the start node, from which we are calculating reachable tiles. Then create two lists, open and closed lists. Open for yet to be processed nodes and closed list for processed nodes. Now we will need to keep processing the open list until we run out of the tiles to process. So make while cycle for this. Good. Now we will follow the same approach as we did with pathfinding. First get the current node. Because we are sorting all the tiles, we don't need to determine the most efficient node. Remove the node out of open list and add it to closed list. Now we need to calculate all the neighboring nodes around the selected current node. Make a list for the neighbors. Exclude the node of origin, which is in the middle, because it is a current node. Check position to make sure the position is on the field. Cycle through all the neighbors and check if they are not present in the closed list. Check that the node we're stepping into is walkable. Calculate move cost for the neighbor's node. Then if this node is not in the open list, we want to assign g value based on move cost. Because we are not finding the path, we are just calculating all the possible areas our character can move towards. We don't need to assign h value. Assign the parent node. Add the node into the open list. Good. Now, when you select the character, we want to call this method to calculate all the tiles this character can reach. Right now the character will be able to reach all the tiles on the scene. Because we are passing our character of the world map tile map, we can simply store the reference to pathfinding of the target tile map. Call the calculate walkable terrain and pass the click position. Now we want to be able to tell the character to move from his position to a new position, based on pre-calculated path data we have made. Open grid control and let's comment out all the left mouse button controls here. We don't need it anymore and it will only obscure our control scheme which we will be making in character control. Then in the mouse input in character control, if the input is left mouse button, check if the character control is not null. In that case, we will create and call a new method called trackBackPass. Pass the selected character an X and Y position. To track pass back, we will use parent node we have assigned before. Create list for the pass, and inside the while loop we will be moving back through the pass by using parent nodes. When the pass current node is null, exit out of the loop and return generated pass. This will signify that we have reached the character on the map, but later on we should actually use the position of the character to determine this. We will redo this a little later. Now we want to highlight the pass. Create two serialized variables, highlight tile map and a highlight tile. Then on highlight tile map, set tile based on the pass we have calculated. I accidentally put the tile map instead of tile base. My bad. Not target tile map, highlight tile map. Clear the highlight tile map. Good. If I click outside the boundaries, it will cause an error. To avoid this, we need to check the position of the grid. If it is outside the boundaries, we will return null as a pass. Same will happen if I try to select the character outside the grid boundaries. So check for the boundaries in the right mouse button click 2, where we select the character. But we have a boundaries check on the grid map, not on the grid manager, which is available here. So, let's add the boundaries check on the grid manager. Because we will be checking the boundaries of the grid map all the time, and I think we should be able to check boundaries through grid manager. Now we can't reselect the new character, because then it will cause a weird error. What we need to do is to clear the data we generated when we select the previous character. Call and create a new method called clear. Then inside, cycle through all the nodes and clear them. Now if we test it, it might look weird, because for some reason some tiles will not be walkable. The reason is, it is because our check walkable only check for the tile ID to be 0. If it is anything else, it will determine that this tile is in fact unwalkable, which makes our grass tile an unwalkable terrain. We will change this later. Right now we can select any character on the screen and then determine the path to move this character. But we still don't have a system to limit the range of the character movement. Open Pathfinding script. We need to pass two additional parameters. One for range of movement and one will be a reference of the list of nodes, which you need to highlight for players to see as being available to move. Because our distance is calculated in factors of 10, let's simply multiply path range by 10. And inside the neighbor's calculation, check that range is less than move cost to this point. So if the node is too far away for our character to reach, he will not be able to reach it anymore. Now we need to fill the referenced highlight list. Check if the to highlight list is not null, and in case it is not null, fill it up with all the processed nodes from the closed list. Using referenced list is useful in this case, because if you pass null instead of list, that means you don't need to highlight anything. This is useful in cases like AI functions. We are done here. Now let's move to the character control script. Here, add the missing parameters. Add the selected character move distance, which we need to make public, so we will be able to access it, and reference the list. Good. Let's test this. Good. As you can see, grass patches represent obstacles for us, and that causes the character avoid them. Good, this is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. Special thank you to Andrew V. Long for his generous support. With best regards, see you in the next episode.